All right, so today we're doing 49 group anagrams. Given an array of strings, group the anagrams together. You can return the answer in any order. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. Let's take a look at the first example. So we have the strings eat, tea, tan, ate, gnat, and bat, and we're grouping the anagrams. So bat is part of its own group. Then we have gnat and tan. Then we have ate, eat, and tea. So the most important thing about this problem is understanding exactly what an anagram is. So suppose we have the word tea, and we want to find the anagrams for this word. What would they be? Well, you could have eat, you could have ate, you could have T-A-E. So now if we want to group these, we have to think about how can we quickly determine whether a word is part of a group or not. Well, what we can do is sort it lexicographically, and that should be able to tell us whether or not they're anagrams. So let's just go through each and see what happens. So let's sort T, and we have A-E-T. With eat, it's going to be the same, A-E-T. For ate, A-E-T. And for te, A-E-T. So to group these, what we can do is we can use this sorted string as the key in a hash map. So our key is going to be the sorted word, and our value is going to be all the words that, when sorted, equal the key. So here we would have tea, eat, ate, and te. And that's basically the algorithm. So I think we're ready to jump into the code. So the first thing that we can do is initialize our hash. So it's going to be a record where the key is going to be a string and the value is going to be an array of strings. Next we have our loop. So we're going to iterate over each word in the strings array. And let's create a key. If you remember from the walkthrough, the key is going to be our sorted word. So we can spread word, let's sort it, and then we can join to turn it back into a string. Next, what we can do is we can initialize hash at that key with an empty array, and then we can push our word into the array. All right, and the final step is to return object.values of our hash. Let's give this a run and see if it passed the tests. All right, and let's submit and let's see how this goes. Perfect. All right. So now let's talk about the runtime complexity of this. So we have our loop, which is going to be O of n. We also have this inner sort, which is going to run big O of n log m, where n is the length of the strings array and m is the length of the longest word. So the overall time complexity is going to be big O of n squared log m. And the space complexity is going to be big O of n, because we are creating this hash to store all of our words.